Now let's understand the concept of concordant and discordant pairs. For any binary classification model, the prediction probability score of a positive case should always be higher than the predicted probability score of a negative case or a zero case. This is what is called a concordant pair. If this rule is flouted, then that pair becomes a discordant pair. Let's understand this with an example. Say you have y here and y hat, the probability scores here. Let's take two positive cases. Yes, yes. The predicted probability score of this one is say 93%, and for this one let it be 70%. Let's take another pair. This is no. These are zeros. For this one, let's say this is having a probability score of 35%, and this is having a score of say 75%. If we keep a cutoff score of 50%, then this will be predicted as 1. This is an incorrect prediction, but that doesn't matter. Let's ignore this for now. When we use the word pair, we are referring to a case where we have a true yes and a true no. Or this could also be a pair, this could also be a pair, and this could also be a pair. All these are pairs. We have four pairs, four possible pairs in this case. Now let's take the case of these two pairs. The score of yes is greater than the score of no. So this is concordant. Let's take these two pairs. The same applies. The score of yes is greater than score of no. But if you take these two pairs, the score of no is greater than the score of yes. So this is discordant. Whereas all the remaining three pairs are concordant. This is the concept behind discordant and concordant. Now, suppose if we have 1000 rows in your data set, out of it 400 are true positives and 600 are true negatives. How many possible pairs are there? It is nothing but 400 into 600, which would be 240000. These many possible pairs are there. We take each and every pair and check if they are concordant and discordant. Suppose 90% of the pairs are concordant and remaining 10% is discordant. That means the probability score of the zeros or nos is higher than the probability scores of the corresponding positive cases. Now this is model 1. You have another model where you have say 88% of concordant cases, 12% discordant. If this is the distribution of concordance and discordance, then you will always go with model 1 because this has a large number of concordant pairs. This does not depend on the probability cutoff score that you may take. In most scenarios, the probability cutoff score may be something like 0.5, but irrespective of whatever cutoff score you are taking, these numbers don't change. Let's compute this in R for our bank marketing example. I am loading the dataset and building the logistic regression model using GLM function and setting family as binomial like we always do. The model is now ready. You can use the concordance function present in information value package. If you have not installed it, use install.packages information value, both V and I are in caps. Use this function to install the package, load it up. These are the predicted values, actual values. I am explicitly reducing 1 from the actual value so that the zeros will actually have the value of 0 and ones will have the value of 1. Now pass both of this to concordance function. You will get the output. From that output, you can get the percentage concordant and percentage discordant. This is a fairly good model.